Welcome to Abrar Electrical World. This is another video lecture regarding the distance protection, and the topic is overreach. I have made one video lecture already on the underreach, and this is the second one. In total, it is the third one, but the second one in a sense that it is about the overreach, and first one was the underreach. So let's start this, as some of the students requested that I should make some distance relay video lectures and also bus bar protection. Therefore, I have started this distance protection, and also in parallel, you will see the video lectures of bus bar protection. And as I told you that I am covering the topics first, which are difficult ones and not very clearly mentioned in the books. So therefore, I am touching those topics. Now, what is the reach of distance relay? This I already described in under reach, but you know that the reach means the relay set value for which the relay is set. Like for zone 1 relay is set at 80% or 85% of the line impedance, then this is known as the reach. So reach is what? Reach is actually the value you set for the relay, and the relay should operate a value of impedance measured during the fault. When the value measured during the fault is less than the set value, then the relay will operate. Now under reach was that the relay, when the relay impedance was, when the relay fault, when the line fault was within the zone, relay did not operate. That was under reaching. But the overreaching is, that is the reverse of that, that the relay operates out of the zone faults. Like so fault in zone 2, or fault is in the next bus bar section and the next line section, and the relay operates in the first zone. So that is known as the overreaching of the distance relay. I will explain this by drawing a circuit diagram, as I did in case of underreach. I have drawn all the drawings myself, not taken from anywhere. So overreaching is observed where it is usually observed in double circuit parallel lines. You see, mostly the towers are double circuited, and one line is sometimes off for shutdown and maintenance, and it is grounded. Then there is a effect of the mutual reactance between the two lines, or the mutual impedances between the two lines, and that affect the measurement of the impedance of the line in case of a fault. So the theory behind, I am not touching here. You can calculate. There are formula available for that, but that is not the scope of our lecture, because we are concentrating basically on the practical aspect plus the application of the relays and the causes and reason in these kind of video lectures. For the formula, you can always go to the book and you can find the formula for that, how it is calculated. Now see here, I have drawn a sample diagram. This diagram is drawn by me on the on this Microsoft PowerPoint. You can draw the diagram from there also. So I draw the diagrams from with the help of the PowerPoint. Now you will see that I fault, assume a fault on the section P and C, and this line is on, AB line is on, line 1 and line 2 is off for maintenance, and it is grounded. Now what happens when there is a fault in this one? The relay at this point A, which is set first zone up to this 80%, and the next zone will be the rest of the line plus 25 or 30% or 40% of this line. I have assumed that this point is within the second zone or maybe third zone. But this relay here may operate on this fault, which is a wrong or incorrect operation of the relay. This will happen, as I told you, that this will happen because of the mutual impedance between the two lines, which is grounded and which is not grounded, which is energized and feeding the fault. So the measurement of this line up to the fault is affected due to the grounding of this line. So This is known as the overreaching, that this relay is overreaching the setting which is already done. What is the setting? Setting is, for this line, zone 1 setting is 80% of this line AB. Now, if this line, this breaker or this relay is operating on this fault, which is beyond the setting of the zone 1, and relay is still seeing it in the zone 1 and operating and tripping the circuit breaker, isolating the fault from the bus bar A, then it is not a correct operation, because this bus bar will be dead. Actually, this fault must be cleared for, by the relay at this point here, right here, not at bus bar A, not bus bar B. In the second zone, the bus bar A can operate, and in the last zone, which is, I told you in some lectures, that is the non-directional, the B can also operate and look into this fault. But that is the last resort. So this is very brief and simple explanation. I tried to draw this diagram and tried to explain to you. I hope you understand this. Now this is a small formula of the percentage reach of the relay, or reach of the relay. ZF is the effective reach and ZR is the impedance setting. Effective reach means the relay, effective means the impedance measured by the first impedance of the first line and plus the impedance of the second line up to the fault. So that is the effective reach, effective impedance, and this is the impedance setting of the relay. So when I say ZF reach, it means the effective impedance. So this is it. So what is done? Actually, whenever in a parallel line or double circuit line, shutdown is taken of the line, then the relay setting of the energized line should be reduced by a certain percentage. By 15-20%, the settings are reduced for that period only for which the line is under shutdown, other line is under shutdown. So this is usually to be done. Some engineers or companies give a figure, and that figure is like 20%, 25%, 15%, etc. So this is I have tried to cover this topic very simply, and just keep in mind that overreaching is that the relay is operating for a fault which is not in the first zone, or if it is in third zone, relay is seeing in second zone. If the fault is in the second zone, the relay is seeing in the first zone. That is overreaching. And the reverse is that if relay is not seeing the fault in its effective zone, that is the set value, then it is the underreaching. So these two you must understand very carefully. Sometimes it looks confusing, but it is not very difficult. I had tried my best to explain this in a very simple language and with the help of the very simple diagram. So I hope you will enjoy this. You will understand this. Please share, subscribe, and like our channel. This is exclusively for the engineers, the students, and free knowledge distribution and the spread of the knowledge. It is our duty as senior engineers. So this is all for this video today.